Plotting trig functions on the xy axis is important to do. We have y is a function of x, specifically sine of x. It's plotted like this. Alright, this is 1, this is minus 1. This cross here occurs at pi. This completed period occurs at 2 pi. And cosine is just a sine wave shifted by 90 degrees, or pi over 2. So it starts at 1 here, and then it has the same behavior. And that first cross with cosine, I should write this y, x. A complete period occurs here when it gets back to 1 at 2 pi, of course, and at pi, halfway here. And quickly we'll put pi over 2, 3 pi over 2, and that's 1 period. We have pi over 2, 3 pi over 2. So we're all about graphing trig functions on the xy. The parts of the plot here are this distance right here, amplitude, which is going to be the same distance here. The amplitude or the magnitude, the max height of this wave is this a value. So on the regular sine of x plot, that amount is 1. If you're asked about this, a magnitude or an amplitude is always a positive number because it's asking for this distance. So if you see this function instead, y equals negative 3 sine of x, well, the way to draw that is to go this way, and to also note that this is going to be negative 3, and then the max height over here, positive 3. If you want to know what the amplitude of that function is, it is 3. So you'll take this amount right here and just make sure you put these magnitude bars on it, which gives you the positive value, which is how we get that word magnitude, is this same idea. So it's just saying how strong does the wave peak. If you have y equals 400 cosine of x, then you have this graph, and it just goes, here we go, from this. Remember I said this was 1, but here it's not, it's 400. Boom, 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 down to minus 400. Alright, the way to write it properly is this: for y equals a sine of some value here, amplitude is equal to the magnitude of a, the absolute value of a, and also for this, okay, a period in these terms, we're going to say it's the length of a full cycle. So a full cycle is complete when the periodic behavior shows itself. When the function repeats, when you've completed one full period and it appears to happen again, right? This happens continually to infinity. It keeps doing that. We have a third color here, right? This is one period from here to here. And the way we write it in the form of the equation is, let's see, for this, y equals sine of bx, period. And this one's a little fun and interesting. Now you get an equation, or really a definition, I guess. Period is 2 pi over the magnitude of this value, b. So the reason that's true is because you're taking the original graph right here, the standard basic sine graph, which goes 1 to 1, and it goes to here and repeats at 2 pi, right? You take the original sine function, which repeats at 2 pi, has a period of 2 pi, and then when you have a value here, you have some sort of other period, okay? You're dividing the period of the standard basic normal sine function by this number being multiplied by your x value. It's saying take this 4 right here, divide the period of the basic sine boom, like by that, and now you're going to have the period of the function you're looking at. So just know that if you have this 2 cosine of 23x, if you have this, here's your amplitude, and then this needs to be put under 2 pi, right? to get the period because it's no longer the basic cosine. A manipulation or a transformation of it is different plot, which has a different period besides 2 pi, and that period is this amount, 2 pi over this b, okay? Make sure I'm clear too, the magnitude of this. So if this is negative 23, it needs to be over the magnitude. What else do we have? Frequency is also important to understand. The frequency of this wave here, it has a period of 2 pi. Frequency is 1 over the period. Okay, so in my opinion, an easy way to understand period and frequency is to look at durations of time, which is often how you'll see trig functions used in other applications outside of a trig class. So if this axis were time and you had sine of t, right? This period right here, t, for example, if this made up sine right here. So that's one period, which is going to be in some amount of time. So let's say each of these is a second. That means that's 4 seconds, which would mean an entire period in this arbitrary example is 4 seconds long. So a period is a duration of time. So after 4 seconds, a period is complete. Now, if we take the inverse of period, right, we get frequency. And so then the way to think of that is, remember, one period is 4 seconds. If you go around this circle now, right, tick-tock, 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 4 seconds has occurred, right? It'll take 4 seconds to go around. So tick-tock, tick-tock, 4 seconds. Tick-tock, tick-tock, 4 seconds. Tick-tock, tick-tock, tick-tock. So one period takes 4 seconds to occur, and then frequency, the way to say that in words would be, how frequently does a period occur? It occurs once every 4 seconds. If you read this, it says once every 4 seconds. So if you have 1 gram for every milliliter, 1 gram per milliliter, here you have 1 instance per 4 seconds, 1 occurrence per 4 seconds. That tells you that this thing with a period of 4 seconds, right? An entire period lasts 4 seconds. It has a duration of 4 seconds. Its period is 4 seconds. And how frequently do we see a full period, a full cycle? Once every 4 seconds. So I just wanted to show that so you can have an intuitive understanding of period and frequency. Period is going to be in seconds, and frequency is going to be in inverse seconds. And the way to write that is like this. But in this trig class, what you're going to see most of the time, right, is that you have this angle theta, which is simply turning in the counterclockwise direction around the circle, right? So one period is going to be expressed as an angle. So that's why you see, like I said, this period of sine is 2 pi, because we're saying 2 pi radians are covered when you rotate this ray completely around the circle. And same goes for this. We're usually looking at sine in this way. So a period is 2 pi or 360 degrees. And then that would imply that the frequency then would be expressed right in this way, at least for sine. How frequently do we see an entire period? How frequently do we see a full cycle? The answer is, so in words, how frequently do we see a full cycle? Answer, once every 2 pi radians. Does that make sense? One period is 2 pi radians. The frequency of a period taking place is once per 2 pi radians. Frequency equals 1 over 2 pi. So frequency is 1 over the period. Period is 1 over the frequency. The frequency is the inverse of the period. The period is the inverse of the frequency. Okay, so next thing to think about is a phase shift. And all a phase shift is if you have, always start with sine of x here, not 6. If you have sine, and again that means this is 2 pi, this is 1, This is -1. A phase shift is, remember we manipulated the amplitude, we manipulated the period. So phase shift is manipulating this. Remember there's an invisible A here, and then an invisible B here in front of the X. Right now we're just using this C to say the function is shifted to the right or to the left. Remember this is X and this is Y. The way I like to think about that is a phase shift is when you take your wave that you're looking at and shift it in the X direction. So that plus C is you have a point here and a point here. This distance is C, and I think that's pretty intuitive. Remember, this continues in both directions this way. So you might notice then, okay, well, when I have this function, right, because I have one here, a period is 2 pi. It's interesting, huh? Cosine of x is sine of x plus a 90-degree shift, so plus pi over 2, which can also be written as sine of x plus 90 degrees if you like, right? So this amount shifted here, the sine graph, all this cosine is my sine graph shifted in the x direction that much. So to demonstrate, it peaks here at pi over 2. Let's shift it by that pi over 2. Let's just shift it that much, right to there. You'll notice that now we have cosine. And just as a note, positive is a shift to the left, and negative is a shift to the right. I should mention that. So let me make sure I'm just clear on that. So if we have y equals sine x plus pi, it will be this sine plot shifted to the left by pi amount. And if we were to have minus pi, write it just for you guys. So let me see, pi, 2 pi. If you have the minus pi in the argument, then we're going to shift this by 1 pi. Boom. In the positive direction. So it's opposite of what you see here. And then the last piece, we have the graph being shifted up or down. So you have sine of x, and then outside the argument is this d. It's just one of those things you have to remember, but now when I tell you to shift this plot, your original sign, I'm going to say, oh, well, it shifts up when it's positive. If the amplitude here is 1, as it is in the basic sine of x, then it's going to be shifted up this amount, d, whatever it may be, this distance right here, d. And then, for example, cosine of x plus, remember outside the argument here, so plus 5, then the original cosine function that we have would go from 1 to -1 here, and our shift that we get in the y is going to be up 5 units. So phase shift is when you have something in with the argument of the trig function. So x plus c. I just remember that it's something that's occurring in the x direction, and the rule for x is this shift will go that many units to the left, and this shift will go that many units to the right, okay? And then a vertical shift is one that occurs outside of the argument, so that's how you can kind of think, oh, this affects the y because it's plus d, whereas this one is affecting the x because it's in here in the argument with the x, and so this will go up and down. Plus in the y means plus d, and then minus in the y means minus d. So the full general equation, as we call it now, we have a sine bx plus c plus d. We have our magnitude, our amplitude, we have our period, which is based on b, we have our horizontal shift, and then I run out of colors, which is so sad when it happens. Amplitude, which is the magnitude or max height of the function, the wave, the graph, the plot. All these words will be used probably at some point. Remember that the amplitude that we're looking at is equal to the absolute value or the magnitude of that very A that is in there. And the next thing is this B. B tells us about the period. Period of wave is 2 pi over the magnitude of B. And we have our C, and that's the shift in X direction. So shift the original function to the left. C units if C is positive. Shift right C units if C is negative. Good. And then D, shift in Y direction. Shift up D units if D is positive. Shift down if D is negative. We'll obviously go through a bunch of examples of this stuff to the point where you can't unsee it. You're seeing it in your dreams. That's how you become an expert. So we have this guy, y equals 2 sine of an argument 3x minus pi over 2 plus 1. And I'll go in here with the highlighter, going through my amplitude, my information about the period, my phase shift or X shift. Sadly, I don't have another highlighter, but we'll do that. The amplitude of the wave is going to be 2, okay, which means it's going to go from 2 to minus 2 since it's sine. The period is 2 pi over 3, and the X shift here, so phase shift is pi over 2 to the right. Remember, negative in the argument or negative effect on the X is shifting the graph to the right. And then last but not least, we have blue y shift of 1 upward. Cool. So let's draw it then. I'll do period 2 pi over 3, so I know what a sine function looks like. It looks like this. Okay, I'm going to go right here and just say, okay, that's 2 pi over 3. In your class, they'll probably make you do the math and say, okay, so what's this, and what's this, and what's this? Break it into quarters, and we can do that. But first, we'll say, also, it's shifted to the right, pi over 2. So if this is 0 here and this is 2 pi over 3, halfway between that is going to be dividing this by 2. So I'm going to say 2 pi over 3 over 2 equals 2 pi over 6 or pi over 3. So that's how I know what this is. And half of this distance is pi over 6. So that's basically pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. This is 3 pi over 6, which is pi over 2. The graph is getting in my way there, but it's okay. And so my shift here is going in the positive x direction by pi over 2. I will say, okay, then all points on this graph are going to shift to the right by pi over 2. So that means this point here on the graph is going to move pi over 2 to the right. This point on the graph, right, the whole graph's going to move. What I could do is add pi over 2 to this and then move it from here. Add pi over 2 to this. I'm going to add pi over 2 to this because pi over 2 plus pi over 2 is just pi. So it makes it easy for me. So I'm going to say 1, 2, 3 ticks is pi over 2. Then another 1, 2, 3 ticks is going to be pi. I need to shift this whole graph to the right by that amount pi over 2. This point here on the graph, if it's going to be shifted to the right pi over 2, this point here, down here, will end up at pi. So I'm going to do that. I'm going to put my pen on the point right there actually, and just shift it over to the pi. And it takes the graph off the screen, but you know, so what you can also do is just go from 0, take the 0 point, and shift it to pi over 2. So I'm just going to do that. Boom. Kind of goes off the screen, but that's what it'll look like. Let me see if I can maybe... So shifting it pi over 2 puts it there. So you can see that this little bit here comes up through pi over 6, goes up to 2. Okay, so it's been shifted to the right by pi over 2. Then the last thing you have to do is shift it up a single unit. So we're taking the whole graph, we're shifting it up about 1-ish according to my eyeballing here. but you see this is 3. So let's zoom back in. Now this sine, it goes as high as 3, but if you look at this distance here, so the center now of the graph, this part here is now at 1. So the magnitude is, you can check, it's still 2. It's a magnitude of 2 because it's from this 1 up to 3. Still a magnitude, a distance of 2 there. And then same for this negative direction. It's going from 1, here's 0, here's -1. This is supposed to be -1 here. This is much better to do on graph paper. Anyway, so the middle from 1 to -1 is a distance of 2 as well. That's just how you can check that. So that would be it. Sloppy looking, but you know, the clean way to draw it is just here. Then you have, let's bring out the graph paper. A clean way would be, we have 1, 2, 3, 0, -1, -2, -3. This is pi over 6. The best way to get good results is not to just freestyle draw it like I was doing, but it's to eyeball some points as they'll end up. So this is the center of the plot as we saw before. I believe since we shifted it by 90 degrees, it should look like a cosine. Makes sense. So there's a point there. There's going to be another point halfway. It's going to be at -1. Then, sure, pi over 3, doubled, 2 pi over 3. Back down here, back up here. So then it'll come down there. It'll come up here. It'll come down here. And it'll come up here. And it does that. Keeps on doing that. And the last thing I'll add is that if you have something like this instead, say inside the argument, it's 3 times x minus pi over 2, right? If you're looking at this, this is your b and this is your c, then your phase shift is c over b. I saw a few examples that look like this, but the phase shift is c over b in this case, but it's just all about how you write it, because if you take this and bring it down here, this is the same as that, right? So then it would be back to, then this is B and this is C. And now your phase shift is just this, just the C. It's just a small thing. It depends how the question looks on the homework or the test. So just try to remember that. Don't get caught out if you find this happening, right? All I'm saying is it's just, this is not the same as this, right? That's not a trig thing, that's just simple algebra stuff. So if I get this on a problem, like I said, I'm going to rewrite it. That way I have my B and my C. Just a tip. Let's do problems. Here we have a problem. The function y equals cosine of 6x has an amplitude of blank and a period of blank. This has got to be easy for us at this point, right? Amplitude of 3, because we see it's here in front of the trig function. And a period of, the period is not 6, remember it's 2 pi over that 6, and that is pi over 3. So pi over 3. A nice true or false question. These are fun to get things started off. The graph of the sine function has infinitely many x-intercepts. That's a interesting philosophical point they're making there. Luckily, I went over this many times when I gave examples, because I always do this, dot, 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 this dot, dot, dot here that I add every time. It's just for my own sanity, right? If the plot that you're given looks just like this, maybe there's arrows like this, sometimes you might see that. Just know that this goes off to minus infinity, this goes off to positive infinity, and these are x and y axes. The answer is, it's true, yes. The x-intercept is here, 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 and if I do this with the zoom out function, remember this plot does this forever. So it's also here, 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 here. If you're wondering how many x-intercepts are there, infinity. Okay, next question. To graph y equals 3 sine of the argument minus 2x using key points, the equivalent form blank could be graphed instead. Remember, we learned in a previous video, I believe, that Sine is odd. Cosine is even. This odd and even stuff is one of those things that it took me a second to catch on to also. Like I remember being in a class, and then in the course we were like odd and even, and then we would move on, and then I would get a homework problem that would just require me to call on the odd and evenness, the symmetries, and I didn't think to, right? I knew the properties of the odds and even functions, but I didn't think to call upon them. So it's just a good question for me to practice here, is to help you think to recall these truths. So sine is even, cosine is odd, which we talked about also, just means this. The fact that it crosses the y-axis here, the fact that it crosses here and goes negative makes it odd. And then cosine, the fact that, so you always draw cosine like this going to the right, but remember, it's infinitely going in both directions. It's a wave propagating. Here, when it crosses, it's going from positive to positive. So sine is odd because it changes sign. That's sine. It's two signs there. Sine is odd because it changes sign when crossing that y-axis. And cosine is even because it keeps the sign. So this function is also even, right? It's not just that it's positive, it's that it's the same sign. So it starts negative, crosses the y, and remains negative. That's an even function. Okay, good. So since I wrote all that, that's just to justify saying the rules of odd and even functions. So if function's odd, then that function with a negative argument is equal to the negative of the function with the positive version of that argument. And if function is even, then the function with a negative argument is equal to the function with the positive argument, the positive of the same version of the same argument. So it has to be negative x here and x, right? This is from a previous video. I just wanted to say that. So that being said, to graph y equals 3 sine minus 2x, since sine is odd, we can also just say y equals negative 3 sine of 2x. Good? So the answer is D. Determine the amplitude and period of each function here. So my amplitude is 2. The period of sine is 2 pi. The period is not manipulated in any way. So period is 2 pi. Good? Let's try another one that maybe is going to be less simple. It's not. So amplitude is 3. Period is 2 pi because it doesn't change. Next, amplitude. Remember, be careful about this. If this is RA, the amplitude of this graph is 4 because here A is negative 4. So A is negative 4. Absolute value of A is 4. So the amplitude is 4. And then period is 2 pi over this B, which is 2 pi over 2. Sorry, I didn't mean to circle this. Make sure this is B, right? Because it's B times X. Only this 2 is B. So the form is, so pi, period is pi. Box it, box it. And the next one, y equals negative sine of the argument 1/2 x. The amplitude, this is a secret minus 1 is what our A is. So our amplitude is positive 1. And then this 1/2 is our B. So period is 2 pi over this 1/2, which we like to do 2 pi times the flip instead. So 4 pi. Period, amplitude. Write the equation of a sine function that has the given characteristics. So it's sort of the reverse of what we just did. I'll write out as always. So I'm not going to have a C and I'm not going to have a D because that's phase shift / X shift and that's the Y shift over there. So it's not going to have either of these. So it's going to have this form right here only. And the amplitude is 3. So let's say 3 sine, and then the period is pi. Period is, of course, 2 pi over B. So what is my B that I'm going to put in front of the X here? Well, it is. So we don't have b, we're going to have to solve for it. So period is 2 pi over b, and period is pi, right? That means you have this equation, pi equals 2 pi over b, right? We just wrote that. It's good to write mathematically, sort of just take notes as you're working, like period is equal to 2 pi over b. We know that's true from literature. And the period is given as pi. So the period is also equal to pi. Another way to write that is period is pi, period is defined as 2 pi over b, right? And then when you combine these two equations is how you get that. So pi equals 2 pi over b. So I always think about this as this 2 pi is being multiplied on the right. So to get it away from the b, we need to divide both sides by 2 pi, which means we need to divide this by 2 pi. So pi over 2 pi is equal to, that'll leave a little 1 here. And then if we just take the inverse of both of these, aka just flip the fraction, then we'll get this. So then we'll know that our b is 2. All right, sounds good to me. And that's your answer. Same deal here. Y is equal to amplitude, that's my a, sine of some b, which we need to solve for, times x. So period is defined as 2 pi over b, and the period is given to be 2. So period is this, and period is also this, then that means 2 equals 2 pi over b. Doing some algebra, we have 2 over 2 pi, it's 1 over b. Move this way because I'm out of space. 2 pi over 2 equals b. b is equal to pi, it looks like. So we'll put a pi right there, and that one's solved. Graph the function using transforms. Be sure to label key points, do 2 cycles. Use the graph to determine the domain and range of each function. Good. This is good practice right here. So we'll start by drawing this x and y. I'm going to determine that we have an amplitude of 5. Okay. You might think, oh, I'll just label 5 and 5, but it's also going to be shifted -3. So that means we're going to need -8. That means the part of the graph at 0 is going to go down to -3. So if I have an amplitude of 5 and the graph is shifted -3 in the y, and it's a cosine with a b of pi here, period is 2 pi over b, so my period is 2. So a nice way to do that is to come here and just write 2. Now it can also be a little daunting when you're going between values that have pi in them and values that don't, but just remember that it's okay. This out here, say this is 4, 3 must be here, then 3.14 is just right here, so your pi is there. You'll see a lot of these plots, pi over 2, pi, 3 pi over 2. You'll see this happening lots, okay, but it does occur where you have just these integer values that don't have pi in them. But you could just think in your head, okay, 3.14 is right here. It's no big deal. If I get a period of 2 out, I'm just going to write the graph with an x-axis labeled with 2. And so I know an entire period is 2, so that means that here at this 2 is where our cosine is going to repeat. So when they're talking about key points, they're saying choose some points that you know are definitely going to happen. So one I can say is if x is 0, right? Well, when x is 0, the plot is going to say this value. I know for a fact that cosine of 0 here is 1. So that means this equals 5 times 1 minus 3 equals 2, right? Because that's 5 minus 3. So I know that when x is 0, my y value is 2. So we do 1, 2, 3, 4, 5. Okay, 2. So I shouldn't have drawn a point here. I just wanted to show where the origin is. But actually, so here's a point on the graph that we're about to draw where x is 0 and y is 2, right? And if a period is 2, and this is in the x direction, then that means I surely will see the graph start over right here at 2. Does that make sense? We're gonna see it. We're gonna have a cosine here. So the cosine starts high and goes down. So it's gonna go do back to here. And yeah, so that's one of the key points. I'd say another key point is if x were 1, because again, we've assessed all this information. We extracted this information from the given information of the problem. I know that if I have a period of 2, then the halfway point is going to be at 1. I can either plug in to the function x equals 1, or do a little bit of intuition and say, right, if in the case that instead of it being 0 to 2 pi, what if it was from 0 to just the number 2, which is what we've ended up with? Then halfway would be over here, right? This is normally from 0 to 2 pi, going in the counterclockwise direction. But hypothetically, what if it was 0, the number 2, instead of 2 pi, right? Then this would be, instead of pi, right, it would be 1. And instead of pi over 2, it would be a half, right? So we've changed what one period is. And a period is just going around the point of showing the circle is to show periodicity, right? Is to show that it repeats. So you can look at the circle and see when we get back here it repeats. A wave, like a sine or a cosine function, to behave that way and follow that pattern. So plugging in, if x equals 1, right? Because again, I determined that it's halfway. It's the halfway point of my graph. Starts at 0, halfway at 1, begins its second cycle at 2. So y equals 5 cosine of, and then I'm going to put 1 in for the x. I'm not going to write it because it's 1, so it's just going to be 1 times pi, which is pi. That gives me cosine of pi, I know, is minus 1. That's 5 times minus 1 minus 3. 5 times minus 1 is negative 5. Minus 3 is going to be negative 8. So, as I predicted earlier, right, the value here at the halfway point, which is 1 in the x, at that halfway point 1 in the x, the graph is going to be at minus 8. So you can draw this. So halfway it's going to be here, so we come down, then it's going to come back up, then it's going to be a minus 8 again at 3. It's going to be minus 8 again at 3. And then move this up to make it work. And then it's going to be, whoops, not there, back to 2 here. The y will be 2 once again at 4, so we just do this. So those are the 2 cycles it asked for. Yeah, there you go. This halfway point is just going to be halfway between 2 and minus 8, which is a total magnitude of 10, right? This distance is 10. And so halfway is going to be 5 down from here or 5 up from here. So minus 3. The sketch is a little off, but just know that it's at minus 3. And that's how you would do that. It also wants us to determine the domain and range of each function. So the domain is x's that can go in to the function. The range is y's that can come out of the function. Remember that this goes off to infinity, this goes off to infinity. So my domain, x values that it can take, are going to be x values that exist along this number line from negative infinity to infinity. It's going to look like that weird thing, right? Like this, whatever I just made is going from 2 to minus 8. But in this in the x direction, it just goes. It's a wave that propagates infinitely in both directions. So the domain is negative infinity to positive infinity, and you never put the brackets here because you can't say it includes negative infinity or infinity because it doesn't make sense. And then the range is all y values that could possibly occur or come out of this function, which, as I've wrote a few times now, is from positive 2 to minus 8, and you write it from low to high. So including minus 8, which is the minimum, and including, that's what, make sure brackets mean include, right? So that's your range, is from negative 8 to 2. These are all the y values that can come out. These are all the x values that can go in. Okay? Find the equation for each graph. This is the kind of thing you might hear a professor say or read in a book where it says by inspection, do this or that. So to find an equation for this graph, I have to inspect a few things. First thing I'm inspecting is that the top of the graph is occurring at y equals 5. The bottom of the graph is occurring at y equals minus 5. Begins like this, which tells me it's a cosine, or a shifted sine, but I'm just going to assume it's a cosine. And I also see that we begin here, and when we get here, it looks like it repeats. So it looks like that's a period. That looks like it's a single period right here. Okay, so a period by inspection is from 0 to 8, which is a value of 8. If it was from 2 to 10, it would also be 8, right? So you do the greater thing minus greater position minus the lesser, and then that'll give you that distance there. The period t is 8. We have a period of 8. We have an amplitude of 5. So I'll begin writing it and say, okay, looks to me like a cosine with an amplitude of 5. And the argument in here is going to be, so my period, again, remember this is sort of like something you have to memorize, but it's very, honestly, math and physics students have it really easy because other majors have to memorize so much crazy stuff, but we just have to memorize 2 pi over b. I love it. Period is 2 pi over b. So period is 8. So this system of equations right here tells me that 2 pi over b is 8. And doing a little bit of algebra, divide both sides by 2 pi gives me 1 over b equals 8 over 2 pi. Flip means b equals 2 pi over 8, which equals pi over 4, meaning my b is going to be pi over 4. So period is 8, b is pi over 4. And then you put the x there, because the function is working on x, and that's your answer. There does not appear to be any y shift, which would go here, because it goes from -5 to 5. If it went from -4 to 6, it would be like, okay, what's the shift? It's up 1, right? You got an easy one there? Let's see, find the equation for this, okay? By inspection, it appears to oscillate up and down from -2 to 2. And again, if it's from -2 to 2, there's not a y shift. It's from -1 to 3, it would have an amplitude of 2, but have a shift in the y. This does not. So easy. My amplitude is 2. Now, I'm going to say this looks like a sine because see how it's odd? It crosses from positive to negative. But there's something interesting about this sign, right? This is the sign that I'm used to seeing. And yet this one crosses in this direction. It looks like it's either a little shifted in the x. This amount right here. Let me just delete all this. And I'll draw, for fun, I'll draw what I think a sine's supposed to look like, right? And I'll say, this is what sine is supposed to look like. What's going on here? Well, if I shift it, it lines up somewhat, depending on how well you draw, right? If I shift the original sine, so this is y equals sine of x. This blue is y equals something, right? Then if I shift my y equals sine of x, sorry, it's technically this to sine of x. If I shift it either to the right or the left, it's going to have the same effect, as you can see, because of the periodic behavior. If I shift it, let's say, to the left so that they overlap, how much did I move it? So this point right here, where it crosses the x-axis at x equals 2, or where it crosses the x-axis at x equals 0, we watch either of those and see how much it moved. So let's choose this spot. I'm going to watch this spot right here and determine how much it moved. How much did it shift in the x when I move this? So, okay, and now it's overlapping. So it looks like it's a shift of 2, right? Because we're going from x equals 2 to x equals 0. So I'm going to say that the phase shift is equal to 2. And again, it can go in either direction, so it really doesn't matter if it's positive or negative in this case. But yeah, the phase shift we've been writing as c. And those are the two attributes I can see that are different. So, and one more thing to think about is what is the period, because this is peculiar. It looks like it crosses here at 2 instead of pi. So the original sine function period is 2 pi separately, right over here in the corner. But with us, we have a period of 4, right? Goes down here, comes back up, and begins a second cycle here. So that means the period is 4. And since period is 2 pi over b, then that means to find b, I can use this, right? So divide this out. 4 over 2 pi is 1 over b. B is 2 pi over 4. Pi over 2. So now we know our b is pi over 2. So we have y equals this a, so sine of b, which is pi over 2, it looks like, x, plus this phase shift of 2, and there you have it. Right. So now you might be thinking, okay, if our amplitude is 2, couldn't a be either plus or minus 2? What if I made the a minus 2? Well, then you wouldn't have that phase shift, but this is also true, right? Both of these are possible equations for that graph right there. And we can prove it by drawing both of them. So what does this look like if I graph it? Amplitude of 2, period of 4, right? Because it's our B, A, C. All right, so 2, right? And we're going to do a sine. We'll do a period of 4. So we have 1, 2, 3, 4. Here's a period of 4. The sine graph is going to repeat. So it'll go up, down, and up, right? All right, so I drew 2 sine of pi over 2x. And then we're going to shift it by 2 in the x direction. Let me say this is 2 here, right? So 1, 2, 3, 4, 5, 6. It's fine. If I shift it by 2 by going, okay, over 2, now we have that plotted, okay. Well, this is going to come here and keep going. What if I plot this instead? Now, well, my amplitude's still 2, but